So first, we're going to be multiplying, adding, and subtracting vectors. So that's taking two vectors and performing operations on them. Now, it behaves just like you would think it would behave. If you multiply a vector by 2, it's going to double in size. If you multiply by a half, it is going to be cut in half. Um, if you are adding vectors together, you are adding both the x distance and the y distance. So if you're looking over here at this little picture, if we have vector v and vector w, we're actually taking the x distance of v and adding it to the x distance of w, so they end at the same place. Same thing with the y distance. We're taking the y distance of v and adding it to the y distance of w. Basically, where v starts to where w ends when we're adding vectors is our addition vector. Then, if we're subtracting, it works the same except the second vector. So if we're taking v and we're subtracting vector w, what you're actually doing is adding a negative w. So what they didn't show you in this picture was actually w is going in the complete opposite direction like this. And what they had to do to subtract was flip w to go the opposite direction. So you take vector v and you subtract w by making w go in the exact opposite direction. And after we do a couple of these problems, we're going to graph this and you'll see more, it'll be more clear what I'm saying. So now we're going to write down the definition for each one of these operations. So if we have vector v, this one right here, and we're multiplying it by k, what we're doing is we're taking the vector in component form, so a1, b1, and we're multiplying both the a and the b by k. You're like distributing in. Addition, we take our vectors and we're working with v and w. V is a1, b1, w is a2, b2. We add the x terms together. So we add a1 plus a2, comma. Then we add the b terms, b1 plus b2. And same thing with subtraction, but this time we are instead subtracting our x terms, and then we are subtracting our y terms, or v terms. Any questions so far? Okay, let's try. We'll do two easy ones and then one kind of hard one. It's really not even hard. First, we're multiplying 2 times c. So this over here is vector c in component form. We know these are in component form because they have the little arrow brackets, all right? Meaning each one of these vectors we can think of as starting on 0 and going to the point they have here. So what I'm going to do first is I'm going to rewrite the vector in its component form. So c is replaced by -4, 5. And then what you do is you just read that 2 in, and it becomes -8, 10. And you're done. You have multiplied vectors. I'm going to start the same way on number 2. I'm going to first replace vectors with their component form. So a is -6, 2 plus b is 1, 7. And then you take your a values or x values and then add them together. You get -6 plus 1 is -5. And then you add the b terms or y terms. 2 plus 7 is 9. And you have added the. Any questions on those two? So now just maybe a harder one. I mean, it's really not too bad. But first thing I'm going to do is replace the vectors with their component forms. So A is negative 6, 2. Minus B, which was 1, 7. So we do abide by PEMDAS here. Order of operations tells us to multiply first. So we're going to multiply 1/2 times negative. We get negative 3. And we're going to multiply 1/2 times 2, and we get 1. Then we can subtract negative 3 minus 1 is negative 4, and 1 minus 7 is negative 6. Any questions at all about operation on vectors? Okay. So I want to go back up to the page before 7.2 notes, the page we actually skipped last class, this one right here, where we are drawing vector operations. So this is how we're going to, instead of on or algebraically finding addition of vectors, we're going to do it graphically. What I'm going to do is I am looking at number 1, and I'm going to take each one of these vectors, u and v, and I'm going to redraw them on the new graph. Now, this is not, we're not thinking about these vectors as being, or as in relation to the x-axis and y-axis. They are just vectors that have a length, and they also have a direction angle. That's all that we're thinking about these vectors for. So that being said, it doesn't really matter where I draw this on my graph. So I'm just going to draw u, and I notice it doesn't have a y length, but it does have an x length of 1, 2, 3, 4, 5. So it has an x distance of 5. And I'm going to draw it 1, 2, 3, 4, 5, like so. And that's my u. And then, because I'm already where u ended, v is going to start on my new. So v has an x distance of 4 and a y distance of 2. So I'm going to go over 4 up 2. And this is v. Where u started and v ended is my addition vector, u plus v, or uv, as they define right now. And I'm done. Now you could have just looked at the diagram up top and in your head said, okay, so u has an x distance of 5, v has an x distance of 4, therefore u plus v is going to have an x distance of 9. You added them together. And then u does not have 0 y distance, and v has a 2 y distance. So 0 plus 2 is 2. So uv is going to have a y distance of 2. You could have just moved drawn this. But I draw you to see exactly what. Now let's go ahead and do a subtraction one. Because this one's a little bit trickier because, again, remember, the vector you're subtracting, you have to flip around. You have to draw the exact opposite direction that it is going. So first we're going to try z. That one's normal. So that has no x distance, but it does have a y distance of 1, 2, 3, 4, 5 on number. So I'm going to draw, again, does not matter where I draw z. And then I'm going to look up here at w. And I see, okay, so if I'm starting at my starting point, on W. I go down 4, then to the left 3, meaning that negative W is going to go the exact opposite way. It's going to go up 4 to the left 3. So that's what I'll draw here. From where Z ended, I go up 4 to the left 3. And this is negative 2. And where Z starts and W ends, that is our subtraction vector. That is ZW. Yeah. Any subtraction, you always do the exact opposite. Any questions on graphically representing addition or subtraction vectors? So there is another way to write vectors. So far we've learned about just writing a vector in terms of 2 points. We've also learned about the vector in terms of component form. Today we're going to learn about the vectors written using standard unit vectors, or I and J. It's really quite easy. You just need to understand that I and J are just these unit vectors, where I is the unit for the x distance, and J is the unit vector for the y distance. So right here, I is just a unit in length, 1 unit in length on the x-axis, and J is a unit in length on the y-axis. Or in other words, I is 1, 0, and J is 0. Every single vector that is in component form can be written in terms of I and J. Just another way that people talk about. So we can take a vector in component form, and we can write it in terms of I and J by just taking the A value of the component form and writing an I after it, plus the B value of the component form with a J after it. This is the exact same vector as arrow A comma B arrow. Remember from last class, this is the component form. This is the standard unit vector form, or the I and J form. Okay, so let's try it. First thing you always have to make sure is that your vectors are in component form, which ours are in number 1. So I can immediately write this in terms of I and J. This is this notation is also called a linear combination, you can call it. All right. So all we have to do is take the A value, oops, which is 2, and write an I after it, plus the B value, which is 5, and write a J after it. Boom, we're done. That easy. Over here, same exact thing. Take the A value, write an I after it, plus the B value, write a J after it. Any questions on that? All right. Now there's another step if it is not already in component form. They may ask you to first put it in component form. So here, if we're writing a vector that is 2 separate in component form, all you have to do is take y, or sorry, x x2 minus x1, comma, y2 minus y. And this becomes -5 minus 9 is -5 plus 9, or 4. And -6 minus 8 is -14. Then, to write it in component form, I'm sorry, oh my gosh. To write it in terms of I and j, take your a value, write an I after it. Now, I would say plus, but this is a -14. So it's going to be minus our b value of 14 with a j after. Any questions on that? Pretty straightforward, I think. All right. So we're actually skipping this. Don't stop the circle. It's good to look at. But I need to show you this next part because this is how, given magnitude and direction angle, oh gosh, and direction angle, you can find the vector. So I'm not going to go too in depth about why, because it's involving trig, and I think that we just need a little break from understanding trig. But I mean, if you have a good grasp on trig when I tell you this, you may like be like, oh, that makes sense. I'm going to tell you to find the vector given the magnitude and the direction angle. All that you have to do, and I'm going to write this one first. No, I'll write this one. You take the magnitude, and what you're actually doing is multiplying by the unit vector in terms of cosine and sine. So the unit vector in terms of cosine and sine is cosine theta, comma, sine theta. And then you just distribute the magnitude. So to find the vector in component form, all you have to do is multiply the magnitude times cosine theta. That gives you the x value. And then to get the y value, you multiply the magnitude times sine theta. Whoops. If it asks you to write it in terms of I and j, all you have to do is, oh my gosh, take the x value, which is, which is the magnitude times cosine theta, to write an I after it, plus the y value, which is the magnitude times sine of theta with a j after. This is the one you're mainly going to be using. Anytime it asks you to find the vector, given the magnitude and the direction angle, that is the formula you're going to use. And this, when you think about it, I mean, I don't want to go too in depth because you don't really need to know why. But when you're thinking about this right triangle up here that we're looking at for you, cosine is the adjacent side of theta. That's the x value. So it makes sense to find the x value, you're going to use cosine of theta. And sine is always the y value, the opposite side. So it makes sense you'll use sine to find the y value. Okay, so let's try it. And then we'll be done, actually. After this, that's it. We're given the and the direction angle is 60, and it says in component form, find the vector. All we have to do is take the magnitude, which is 8, and multiply it by cosine of 60 to get the x value, comma, you multiply by the magnitude times sine of the angle, or 60, to get your x value. or B value. And then you just pull out your calculator and you do 8 times cosine of 60, making sure your calculator is in degree mode, which mine is already in degree mode. So this is 4, comma, do the same thing for the y, 8 times sine of 60. Enter. And you get, oh, get it, 6.93. And you're done. Would you like me to do another one? One more. So same thing, we're given the magnitude and the direction vector. I'm sorry, direction angle. So all we have to do is take the magnitude and multiply it by cosine of the angle to get the x value. And then you take the magnitude and multiply it by the sine of the angle to get your y value or b value. And then we do 20 times cosine of 225, and we get negative 14.14. And then we do 20 sine of 225, and you get, again, negative 14.14. And you're done. You will have to put the arrow brackets around component form. Also, there was one people were asking about. Oh, yeah. So, we're not doing it, by the way. Okay. So this is on your homework, something like that. It will give you a vector, and it will say negative 2i minus 4j. And it will say find the magnitude and also find the direction angle. So this is kind of how we learned today and also what we learned last time. What do I need to do first to find the magnitude, do you think? What should I do first? We know there are two ways to find magnitude. One is when there's 2 points and we use the distance formula. The other is when it's in component form and we use Pythagorean theorem. Neither of those ways involves I and j. So what do you think we need to do first? Yes, exactly. We need to put this in component form, which is what I showed you earlier, but backwards. So we know how to put it in terms of I and j. To get it out in terms of I and j is just as easy. What you do is you ignore the I and the j, and you put a comma between them. So here, this in component form is negative 2, comma, negative 4, with, of course, our arrow brackets on either side. To find magnitude, you learned last class, you just, when it's in component form, you just take your A value and B value, and you do Pythagorean theorem. With your A term squared plus your B term squared, all square root. So then, now I want to mention this because a lot of people are having issues with this, with the negatives. What happens when a negative is squared? It goes away. Do you think I ever type in, unless I'm telling you guys, do you think I ever type in a negative when I'm squaring it? No. This is the same thing. It's less work. You don't need to write the negative. You know it's going away in both of these. So this is 4.47. And then, how do we do, or how do we solve for the direction? This is a how do we find this angle? Yeah, inverse tangent. It's the formula, inverse tan of b over a. So this becomes inverse tan of -4 over -2. So in my calculator, I'm going to put inverse tan. Now, if I was doing this on my own, this was my own homework, would I type these negatives in? No. What is negative? What is a negative divided by negative? It turns into a positive. And what is 4 over 2? It's 2, but I'll write it. So 63.43. And we're done. Any last and final questions?